Welcome back. So this challenge was really not easy. It's a real world application and there's a lot of stuff going on in there. If you have solved this challenge, really congratulations. You definitely deserve your orange belt afterwards. And if you have struggled a little bit, also absolutely no problem. We go through this challenge right now and we do this step by step. You can pause and rewind this video on a certain point, and I will also provide you some hints. Maybe you only missed a single piece to solve this challenge. This is why I like to provide these hints, because with this hint you might be able to solve this challenge, and it's really just a little hint. So you might have done this if you would have spent several hours or even 1 or 2 days. You will get to this point investing that much time if you start reverse engineering real world applications, but for this course right now it shouldn't be necessary. Therefore it's good to go, take this hint and then try to solve it once again. Okay, so let's have a look. Okay, here we are now at the Ubuntu VM. Let's have a look into the app. So I've put mine into apps, Spacepen decompile. And the first thing I like to do is I like to get rid of old projects. Because if we have modified this version in the past and we are patching it now once again, then we might run into trouble. And this happened to me a lot in the past. Therefore I learned from this and we start with clean projects over here. Alright, then we can decompile this one. APK tool D. Whoops, and the Spacepen application. We go into this directory and we open the whole Smally directory within Visual Studio Code. There we go. Okay, now we can minimize this one. This word is really hard for me to pronounce or to say it loud. So we want to reverse engineer this application first, because what is our task? Our task is to patch the player lives from 5 to, let's say, 7, for example. Therefore, we need to identify this in the Java code. Of course, we can do this in the Smally code, but good luck on this one. So we go one directory back, and I use JDX GUI on this one right now. You can also go for the dex2jar and JDGUI approach, but for me it's now easier to run it in this way. Alright, so let's see. We are looking for, so we use the search function over here. The code or the app gets decompiled. Okay, and now we can enable, for example, field and disable all the other fields over here. Field means we are now looking for the variable name. We search for lives or a live. Live would be the better approach because we've got here lives and also the value live somewhere. Okay. Can we sort this? No, never mind. So here we can see we've got player.lives. All right. We also have this default lives and the attribution or the name live seems to be irrelevant. So we are searching for lives. There we go. Now we've got the player game screen and the player class once again. And let's first look into the player class. This looks promising. We've got our player, we've got default lives equals 5, and we've got an instance field also lives equals 5. This has to be our lives value in our program code or in our application. Nevertheless, also take a look into the other one. In this case, it's game screen. And here we can see, all right, protected final int lives equals 3. We do not have 3 lives, therefore we can skip this one. We are starting and having 5 lives, therefore this is definitely not going to be our correct value. It's super interesting, or at least it's strange that we have these many lives attribution or these many lives variables, but we are having a real world application. So this is what we have to deal with. Okay, so put this side by side now. And then we go into the Smally class. We've got the EFGARBIC Spacepen components and we've got our player class. So the EFGARBIC Spacepen components and this player class over here. I keep clicking these annoying windows and we enable Java. Let's extend this a little bit. Yes, I guess this is good to go. We have talked about this file already in the past, so we are not going through this once again. We can directly see this once over here, public static final default lives equals 5. So this value needs to be patched, or we want to patch this value to 7. Okay, now we have changed this from 5 to 7, but we've got this one over here also. So we also need to patch this one. We can look into the player code over here and see if we identify this. Yes, we can see this right here. Line 39, let's see. Okay, we've got no line attribution over here. So this one seems to not match over here. This is also good to know. We cannot rely on this one all the time. But for now we can see we are having this value 2 times. 5 here and 5 here. So if we are looking in this code for 0x5 once again, we only have this one left. So this has to be this value. Let's patch this also to 7. That should be, right? Okay, so let's save this file multiple times. Then we can close this. We keep this open. And we build this app back once again. APK tool B. This one over here. Let's see if the build is successful, because if we patch the Smiley code and we make a really hard mistake, then the app won't even build, because the compiler figures out, okay, this will not work and therefore throws an error. In our case, we have built this application, which is a good sign, but this doesn't mean we have applied this patch correct. We can still have some errors on the runtime of this app. So if we are putting values into strange registers and things like this, and on the runtime this happens and does not work, the app crashes. But nevertheless, building an app successful is always a good sign. Okay, so we've got this now within our dist directory. Let's make this a little bit bigger. Like that, okay. And now we are using zip-align-v for this one, and we create a new application which is now zip-aligned on 4 bytes, which is named out-apk. Verification successful. Nice. Now we use the apk signer, this command over here, to sign this app. We use the password change it, or at least I have chosen the password change it. There we go. This is our out-apk file. Now let's make our connection to our virtual machine. ADB connect. Connected. Nice. Let's get the screen over here. There we go. Let's see. We have an app already installed. And we can try to overwrite this file, or we can simply uninstall it. In my case, I uninstall this, because this is the most clean way of doing these things. So let's see. ADB uninstall de fgarbic.spacepang. Yes, the app disappeared. Now we can install our out-apk. All right. Let's start this app and see if our patch was successful. The app is loading, that's also good, because we can still have crashes, but for now it's looking promising. We click start and, oh, that's bad. At least the app is working, which is a good sign, but we can see we still have 5 lives. Why is this the case? This can have different reasons. The first one is we did fail on our patch. The second one is this is just a display. So our lives are now really 7, but the display is showing still those lives 5. These might not be synchronized. These might be 2 different type of values. To find this out, we have to die 4 times once again, and if we lose the game, then we didn't really patch this application and the screen was correct on this. And the final case is that we've patched this player lives value, but this one is not going to be used in this code. This code is using a different value. And to find this out, we have to take a look into this code once again, but now a little bit closer. Okay, so let's close this one over here. And let's get back into this code. So let's open this once again. Okay, so we've got these 3 variables, but none of these seems to be our lives value. I mean, this one can be theoretically still be possible, but it starts with a value 3, so I also don't believe in this one that this is the correct value. Now we have to extend our search. We do not look for fields, we are now looking for the real code. And here we can see, okay, we've got our components player. This one is not the correct value because we have patched this from 5 to 7. This one also, we patched this from 5 to 7, no effect. This one is value 3. Yeah, let's skip this for now. If we do not make progress on this, we might come back to this one. But for now, let's skip this. Next, what's this one over here? Entity factory create player. Info lives equals 5. If we take down a look, this seems to be the last value that gets initialized with 5. So let's have a look. All right. Here we have entity create player world, and we can see this code looks like it's creating a player. We've got the position of the player. We can also see the sprite name of the player. And we have also this one over here, player. We are creating here a new player object named info. And this info lives gets now overwritten. Oh, that's the case. Okay. So we have our player.lives, and these player.lives got patched to 7, this one over here. But now when we create this object, it gets overwritten. Therefore our patch did not take place, because this 7 gets overwritten at this point with the value 5 back again. That's pretty strange, isn't it? Yes, this is definitely strange, and I'm also not sure what's the reason for this. I guess the developer has created this player class to use it as the intended way, that the developer uses this player.lives as an initial value. But after writing this code part here, the developer has chosen, okay, let's make sure that the player starts with 5 lives. I'm not sure what I have initialized. This might be some thinking process why this could happen in this way. But nevertheless, we have to deal with this. This is also no blaming regarding to the developer. I'm really thankful that we have this amazing app to keep practicing on. And you will encounter this also in tons of other applications. So you do some reverse engineering process, you identify this class over here, this player class, and now you know, or you think, okay, this has to be our value over here. We've got this player has lives, and this lives value is 5. This must be our value. And afterwards you patch this and encounter, it didn't work. Because it's get overwritten here. This is what you encounter a lot. Therefore we have to dig a little bit deeper, or like other people keep saying, we have to try harder. Alright. So let's go into this class and figure out where this value is and try to patch this value. We put the side by side once again. Oh. Okay, yes. We have closed this one, and this was good because we are also cleaning up this version. We have modified this player object over here, this lives and this lives, but we do not want to patch or add an additional patch on top of this right now. If it fails, we can try patching all those values afterwards. But I like doing single task patching, and this is also what I recommend to you, because if you patch 2 or 3 things at the same time and you get an error, you do not know where the error occurs. Therefore you have to go back and do it once again. And by doing this, yes, it's at the beginning slower, but at the end we might be faster. Okay. So let's clear this up once again. Then we use the APK tool D. We go into this directory and we open the Smiley directory within Visual Studio Code. Putting those side by side. Keep clicking those annoying windows. Not yet, okay. DE fgarpic, and we are within, let's see, SpacePank services, and then entity factory. Okay, now there are those annoying windows. We enable Java. There we go. Okay, and now you might think, wait, what? This file is ridiculous massive. Are we ready for this one yet? So let's step back a little bit, because this is now really massive. But we do this step by step, and we have to remember what we've learned. First of all, click this away. Okay. So we've got the file structure, and the file structure is the same. Let's get rid of the distracting part. So let's go through this real quick. This is our class. We do not extend an additional class. And yeah, this is the file name of this class. Direct method means we are having private methods and constructors. In this case, only this constructor. All right. From this point until the end, we seem to have only public methods, public static or simply just public methods. Our createPlayer method is public static and returns an entity. Let's try finding this method, and we can do this by searching for createPlayer, for example. Okay, and here we can see method public static createPlayer. This is our return value, Artemis entity. This is correct. This is this one over here. And we provide a world object as a parameter. All right, we have identified our method, and now we only look into this part of the Smiley code. We can delete all the rest, but I do not recommend doing this because we have to add this afterwards and this will be a mess. But if you want to get rid of the distraction, copy out all this from the beginning, from here, .method till the end of end method. And then you have sliced this piece of code out and it will be a little bit easier. Okay, I would suggest let's try doing this. So we make a new file. Okay. Okay, there we have our createPlayer method. It still looks massive, but let's remember back again to our first Smiley patching approach ever. This might be the single piece that's missing for you if you haven't solved this challenge right now. So let's recap this a little bit. Let's have a look into the code. Okay, we are looking for this one over here. This is our player object info, and this player object has a name, or this variable, this instance field lives. We have patched this one, but here it gets overwritten with 5 once again. Now, what can we do to identify this within this code? Yes, we can search, for example, for info, but then we also find all these other info values here. Next, we can do the same approach like we did on our first Smiley patching. We can search for the value 5. The value 5 is not going to be used within this code anymore. So by having this value 5, we might be able to identify this line of code. And then we do not have to understand this line of code. I guess we do. I'm not sure about this one. We will see this later on. But we can do this exactly the same we did in our first Smiley patching. We simply change the hex value out of this. And then we have applied our patch. We build this application back again, sign it, install it, and check it out. Okay? So in case this was your missing piece to solve this challenge right now, I know this challenge was really not easy, because if you try to make your way through this will be super hard. But I have structured this course in a certain way that helps you to solve these further challenges by getting back on this approach we have learned. And this is also the approach that helps you on real-world applications. This is why I have structured this course in this way. So if you couldn't solve this challenge yet, please try this approach right now. And afterwards you feel super great if you have patched this app. Yes, you got a little bit of a hint, but let's do not call this hint. This was just a refresher from what we've learned already. Okay? So please pause the video and then you can rewind this after trying this once again. And for all the other people, I will move on right now with the challenge. So let's see. Okay. Let me get this back. So we are looking in this method, and now we are looking for the value 5. Not over here, we are looking over here for the value 5. 0x5. We only got one hit. Nice, let's have a look. Alright, we've got our local v2 info. Nice, this is now not a variable name, this is now our instance name over here. But who cares? We found our instance. So nice, this one is our player object. Great. This means we are putting here the value 5 into v7, and here we can see v7 gets put back again into v2, which is our player object. I mean, I guess we talked about this, but not in detail. Nevertheless, we do not care about these instructions because this is our value 5, this one over here. Let's patch this. Okay, if we patch this here, it doesn't make sense because we have to patch this over in the real Smiley file. But let's have a look once again here. We can see .line 80. Let's have a look at line 80. Oh, well, nice. We also got the exact line number where we are initializing or overwriting our lives object. We can also navigate using this line 8 number. But please do not rely on this. We have seen this in a few moments before that this is not always accurate. In this case, we are taking this because it seems to fit to our code. We verify if we are really in this line right here by looking up and downwards a little bit. Okay guys, super nice. Now we can search, for example, for this whole instruction over here. Okay, so we're looking here for, okay. To make this clear, here we have copied out the method, only this create player to get, all this distraction away. And then it's also easier to search for this value 5, because here we can see we are not using this value 5 anymore. Let's close this one, that it's not that confusing. Here we are now at the original Smali file in this entity factory Smali. And we have used the string from the ones before to identify this value over here. Now we can patch this to 7. We save this file. I use the shortcut, but to make this sure, okay. And now we can close this and we get back to our process, building this app, signing it, and so on. APK tool B. Okay, let's see if we get build errors. No, that's good. Then we go into this directory. Now in dist, we can see we do not have an out file yet, so we have cleaned this code correctly before. I zoom in a little bit. We are using zip-align. Verification successful. Now we have this out APK, which is the zip-aligned version of this one. And now we are using the APK signer to sign this app. Change it as my password, and I made a typo. Change it. All right. Now we can install it. ADB install out APK. No, not yet. We are uninstalling our first version. Okay. So therefore we use ADB uninstall. Yes. And now let's get back the screen copy. Let's see. All right, looks good. ADB install out APK. There we go. We start this app. No errors. Super good. Start. Amazing. We have changed the lives from 5 to 7 right now. I mean, this is not a big jump. And this can be also a false positive right now. As already mentioned, we can have our player lives and the lives within our display. To make sure that we have now 7 lives, we need to die 7 times. And if the game ends afterwards, we know our patch has been successful. We can see, okay, life is already increasing. Nice. Super nice. Okay, but this was not the real task. Let's try to modify this value and get our lives up to 999. We close this one. So let's get back to this one. We open the Smali directory once again with Visual Studio Code. And we directly jump into the last location where we've been. We now know this line 1417 is our player lives. Let's make this 999. The value is this one, 3E7. Okay, let's save this and build this app once again. Oh, we are getting an error. Let's see. 999 cannot fit into a nibble. Could not Smali file. Okay, interesting error message here. Okay, regarding to this error, what does this mean? We are trying to put the number 999 into a nibble, and a nibble is a 4-bit value, but 999 does not fit into 4 bits. That's absolutely correct. Let's see. Why do we have this case over here? So we go back into the Smali directory with code Smali. Okay, if you struggled at this point, absolutely no problem, because Smali is really hard. And if it's the first time for you acting on those registers and think about the space that those registers provide, this is super hard. It also takes time. It took me quite a while to learn this, so please do not get frustrated. Let's think about this together right now. And afterwards you can also pause and rewind this video once again to solve this challenge. What does this line do? We've got const/4 v7 and then our 999. This value did work. But this one right now does not work. So where's the difference? Yes, of course, regarding to the value. But what is the problem here? And therefore, we need to fully understand this line. Let's look this up. So I'm opening my web browser. And I'm opening this one. And let's have a look. const-4. Oh yes, absolutely clear right now. Puts the 4-bit constants into Vx. Oh well. Don't worry, I made this mistake so often and I still do make this mistake. So this is absolutely no problem if this was your struggle point at this challenge. So now it should be clear. This 1-4 only moves 4 bits, but the program now realizes, wait, I've got way more than 4 bits for this value. Therefore, it throws an error because the compiler noticed, oh well, I'm going to throw away a lot of numbers and this might be not intended. Therefore, I do not move on. I rather print this error that the developer can check this once again. Alright, so what can we do? We can check if this value fits into 16 bits. Let's do this. To check this out, we can do a simple math operation. So 2 times 4 means this is the range we have for 4 bits. 16, that's correct. So if we do this on the paper, let's get out the graphic tablet really quick and then we do this together. Okay, here we are now at the graphic tablet. Let's have a look. So 2 square 4 means we are having 4 bits. And 4 bits seems to have the range 16. Let's check this out. So 4 bits means we've got 2 square 0, 2 square 1, 2 square 2, 2 square 3. This means we've got 1, 2, 4, 8. If we add all those values over here, we get the value 15. But we start counting from 0. This means we've got 0 to 15, which means we've got 16 values. Let's find out how many bits we would need to store this value 999. We can do this on the paper. Therefore, we have to extend this schematic over here. So here we have 2 square 4, 2 square 5, 12, 1024, 2048. Alright, at this point we already have enough values to store this value 999. To not always do this on the paper, we can also use Python for this. So within the bin function, we can insert this value 999. And then we can see, okay, these many bits are needed to represent this value 999. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we've got 10 bits. This one over here. Alright, therefore these 4 bits, if we only store these 4 bits in our value, sorry, this was a little bit bad drawing. So if we only store 4 bits into our register, I guess it was V7, but this doesn't really matter, then the program now encounters, oh well, what is happening to those bits? Are you really sure you want to do it in this way? I guess not. Therefore, I throw an error. Okay, so that's the point behind this const/4 and the error message. Let's get back to this one. And now we know, okay, 4 bits are not enough. If we check this, we can use const/16. This will work. If you want to be a nice hacker and also be resource efficient, then we use const/16. In my case, I do not care about those resources. We are just talking about a little bit of bits. Therefore, we use this one, which means we have the full range from 32 bits. Const, and we remove simply this. This means the default value is 32 bits. And now we can save this. We close this one over here. Okay, so then we go into this directory upwards, and let's see if we can now build this application. apk tool B, space ping app, Alright, we can see the build has been successful. Great, the error has gone. We cannot rely on this if we successfully patch this application yet. But it seems like to fit the Smiley requirements in our code right now. Nice. Let's have a look. So we go into this directory, dist, and here we can see we haven't cleaned this up yet. We now just have to make sure that we are using or that we are deleting the old version and using the new version. So let's get rid of this one. Okay, and now, now we can zip align this one, correct. We sign this application, change it, okay, and then we use adb install out apk. No, we uninstall the original version first. So adb uninstall def garbage spacepan, yes, and let's see. Okay, no app available anymore. adb install. That's correct, because we are using the out apk. So you can see you can make a lot of mistakes if you're not absolutely focused on this one. I tried to install this version, which is the build version, but not the signed version. We have signed this app and this is this one. Okay, so this also happens to me still a lot. Also super annoying things like forgetting to save the Smiley file. Okay, a spacepan. And let's see. Still no errors, pretty good sign. Ooh, okay, still no error. There we go, we have 999 lives. Super great. If you have done this, congratulations. So you have already patched a nice mobile game. And this was not that easy, to be honest. If you would have done this at the beginning of this course, this would be overwhelming. But splitting this up in these single steps, we are now able to patch this application. And you know what? You can also change your score over there already. You can find this in the same class. If you want some bonus challenge, go for this. Apply some high score that no one else is able to reach. Okay? So, have fun about this and congratulations. You well deserve your orange belt. Have fun with this, and in the next one we take a look into if blocks.